All right, here we go. We are in for session number 2. David Gardiner talking through hot dates. I hope this is safe for work or not. I suppose it is after hours, as long as it's after 9 o'clock. Okay, not family friendly, and it's after 9 o'clock somewhere. All right, so I'm going to hide myself from the broadcast. David, over to you.
Thank you, Richard. Hi, I'm David Gardiner, and my talk tonight is on hot dates. So I hope you've come wanting to learn more about dates and times. If you've come wanting to learn about relationships, then this is probably not the place to be. Okay, I'm a software developer based in Adelaide. I work for a company called RL Solutions on healthcare software, and I blog and tweet. That's enough about me. Let's get into the talk because time is short. So dates and times. We've got numerous different ways of representing date and time, and different kinds of date and time. So we've got time. We can represent that as a 24-hour clock or just 12-hour clocks. We've got dates on their own without a time component, and we've got the old problem of the US format versus non-US format there as well. We can have a date and a time together. This shouldn't be too surprising for everybody. We can also include an offset. So to be a bit more specific about where this time might have occurred, we can include an offset from UTC. So here I've got a time which is 9.5 hours ahead of UTC. We could even be a bit more specific than that. We might say we want our date and time and include a region name. And the format of the region name here is significant. This sort of is one of the standard names used by the IANA time zone database, sometimes called the Olsen time zone database. We'll look at it more as to why that's useful in a short while. We've also got calendars. Now, most of us are probably used to the Gregorian calendar, but it's important to be aware there are other kinds of calendars. And if you're doing any kind of application that's going to have to deal with some different cultures or regions in the world, you may need to be able to cope with non-Gregorian calendars. So that's just something to be aware of. Some issues that you might come up against when dealing with dates and times in software. Your application might just use local time. And if your app is only running on your PC and it's not really doing too much, that might be okay. But as soon as you start running on multiple servers, or those servers are located in different time zones around the world, then using local time starts to become problematic. Time zones. This is quite a big topic. We're just going to cover a few aspects of that tonight. For one thing, time zones, they're not regular geographic areas. They are controlled by governments, and so governments at their own whim can decide to change time zones, what areas they cover, and that can happen with as much or as little notice as the government decides. So you don't want to make any assumptions about time zones, that they're going to be around forever and that they have particular qualities that are going to be consistent over time, because they probably won't. Often people will abbreviate a time zone. So we've got some examples here of EST and CDT. Now, the trouble is those abbreviations, if you showed them to an American, they would assume that they were American time zones. But if you're in Australia, you could probably say, well, that looks like a Australian time zone. So the abbreviations are a bit too general. So beware of just using those to refer to time zones, because they could be confusing. So CDT could be Central Daylight Time, or it could be, EST could be Eastern Standard Time or Eastern Summer Time. It's not really clear from that. Daylight saving time in itself can be complicated. So not everybody in the world has daylight saving time, not every time zone. The time zones that do have daylight saving it's not always 1 hour difference. It could be half an hour or 3/4 of an hour. It's not always a standard hour. And the changeover time during the year isn't always at 2 or 3 a.m. in the morning. There are some places that change over at sort of 1 a.m. or 12 midnight, which can mean things get really confusing when you're changing backwards. And there have even been occasions when daylight saving has happened twice in 1 year in some regions. So there's a lot of unusual things, and I guess it's all because it's the governments that make those decisions. It's not software developers. I'm sure we would do a much better job. Well, I don't know. And also client machine time. I think really if you're using any time that's coming from a client machine, be that a desktop machine in a client server architecture or a browser, that time should really be regarded as user data and treated as evil, essentially, that you shouldn't trust it. So if you do need to use that time, then don't rely on that too much. Try and use the server time. You may need to implement some kind of compensating algorithm to adjust the client time, because you don't know if the clock on the client is correct or not. So what about UTC? So UTC, or Coordinated Universal Time, sometimes known as GMT time, doesn't have daylight saving. So that makes it a lot easier because we don't have to worry about jumping backwards and forwards. So that is usually a better choice than local time, because it's unambiguous in that sense. The only reason that you might want to not just use UTC is if you want to be able to convert the UTC time back to the original time for the location. So one example for that might be if you're collecting data from lots of McDonald's restaurants from around different time zone regions, and then you wanted to go, okay, I want to look at my purchases at 9 p.m. at night at all my restaurants. So to do that, to convert all your UTC times back into the local times, you're going to need some more information to store with that UTC time to do that translation. So in .NET, let's look at applying this to .NET and also to JavaScript. In .NET, we've got a few types already in our base class library. We've got a date, time, and time span. The first for storing a date and a time. That's a pretty good name for that type. And a time span for storing a duration. Then as the .NET progressed, they added a date time offset type, which also stores the UTC offset for the time. And there's also a time zone info class, which allows you to refer to the time zone database built into Windows. So if you've ever jumped around inside the registry, you'll discover there's data stored there about the time zone so that Windows understands. Something to be aware of with that time zone info data is that historically Windows only kept the most recent time zone information. More recent versions of Windows do have some historical information, but it's not always detailed, so bear that in mind. Over to JavaScript, and the type that's available there is the date type. Issues with the date type in JavaScript are that some of the specs were a bit ambiguous, and so the browser manufacturers, as they want to do, implemented it in different ways. So particularly when you're parsing a string into a date, different browsers will do that in different ways, and some browsers just won't be able to cope with certain formats. So that can be a problem, obviously. So given that dates and times can get quite complex, are there some things that we can do to make it easier for us as software developers? So on the .NET side, there's a library called Noted Time, and I think this is a really good library to look at if you're doing anything that's got sort of some serious date time calculations in it. So let's have a little bit more of a look at what Noted Time offers. So we have a lot more types in the Noted Time library. So we have the idea of an instant, which is a date and a time, but it's not associated with a calendar. So it's kind of like UTC. And with noda time, it's actually a number of clock ticks since an epoch, which for noda time is the Unix epoch. So that's its beginning of time. It just picked that particular value. For types that are linked to a calendar, we have a local date time, which is a date and a time. There's no offset on it, and it's tied to a particular calendar system. We also have a local date. So unlike the base class libraries, we can actually just have a date without a time component. There is also a local time type, but being a time, there's no date, so it doesn't actually get linked to a calendar, so that's not on this list. And there's also offset date time, which is kind of similar to a date time offset. It provides a similar idea of a date, a time, and an offset, but it's tied to a calendar. We have a date time zone. So this is noda time's abstraction of a time zone database entry. The nice thing about noda time is that it can either wrap the base class library database, the time zone info class, or the IANA time zone database. And so we can choose which source of data we want to use and use the same class with that. We have an offset, which is a type that just represents the offset from UTC. So rather than just a number, we've actually got a strongly typed class there for that. And we've got a zoned date time, which is the combination of a date time zone, a local date time, and a calendar all together. Sorry, that's an instant, a date time zone and the calendar. And then there's duration. So rather than just time span, we've got 3 different types that we can use for durations. So we have a duration type itself, which is just a specific number of ticks, and we can use that to add to an instant or a zone date time. We have a period, and a period is interesting because that can be a number of years or months or days, and that actually isn't an exact amount, because if you add 2 months to a particular time, the result is going to be different depending on what the original date and time was, because some months are longer than others. And finally, an interval is a 2 instance, a start and an end. So they've been quite precise about being able to handle different kinds of durations there. So jumping over to JavaScript, our options here, I mean, there's lots of different JavaScript libraries. The ones I've looked at tonight are Momentis, which is quite a good library which wraps over the date object and provides a bit more of a consistent interface across different browsers. There's also, to do time zone work, there's an extra sort of sister library to Moment.js called Moment Time Zone, which extends the Moment class to add some extra functionality. If you want to write an application and detect where a particular user's browser is running from, then you might also be interested in the JSTZ detect library. This will sort of sniff the browser and try and figure out roughly, or as best it can, what time zone the user is in. In this case, I would still recommend that if you can use that library, that you allow the user to confirm or override that choice, because it may be that it's guessed wrong, and you don't want to annoy your users. You want to allow them to have a good experience. But it's probably a good start to get you in the right ballpark. So some of the features of Moment.js are that it, as well as wrapping the date type, it provides some nice comprehensive formatting functions, some relative time methods, a really comprehensive locale database. Actually, that's probably something you need to be careful of if you want to use that, because it's quite large. If you're going to send that down to the client, you need to be aware of that. In my experience, I haven't found it as good when you want to do calculations between different dates. That might just be because I did it wrong. So maybe you guys and girls might be a lot smarter than me. I'm sure you are, so you might be able to figure that out. But in my case, I found that doing this kind of calculations on the .NET side seem to be a bit more reliable. So here's some examples of using the Moment.js library. So the equivalent of finding up the current date and time is just to call Moment We can pass in a string. We can also switch it into UTC mode. So by default, moment works in the local time mode, but if you want to operate in UTC mode, you just call the UTC method on the object. We can call various manipulation methods there to add and subtract different values. We can call the format method to and pass in formatting strings, or just leave it with the default format. And we can also do durations as well there. And so then the moment time zone library extends moment and adds some extra functionality. So here we've got an example. We've got moment and a TZ method where we're able to pass in a time as a string, and also in a time zone name, using the IANA naming format there. And then that will be able to calculate that back to being a time, and also understand what time zone it's in. Okay, enough slides. Let's jump over to Visual Studio. Okay. So hopefully you can see, and not, Richard will let me know if you can't. We've got a little application here, and actually before I jump into the code, I'll show you actually what it does first. That's probably a bit more interesting. Okay, and it's not Twitter. I didn't write Twitter. This application is called FTPjet because I thought it's to do with airplanes, and I thought, well, I think WebJet was already taken, so I'll go with FTPjet instead. And what it is an application that I invented to sort of schedule flights out of Adelaide. So pretend I'm working at the airport there, and for some strange reason, every flight takes 4 hours, no matter where you're heading to. That's more in the interest of me getting my demo working than anything else. But what I can illustrate here is we've got our times, which sort of go off in 1 hour increments, and we're calculating for the destination what is going to be the local time when our flight arrives there. So we can see that our flight, if it leaves at midnight, is going to arrive in Brisbane at about 4:30 AM local time. So that kind of makes sense because we've got a half an hour difference between Adelaide and Brisbane. If we jump around, we can actually pass in a different time. So this was early this year, and that was the end of daylight savings. So we can see if we go down to here to this third line that our daylight savings is finished there. So we've got from 10:30 back to 9:30, and we're still able to calculate all the correct local times there. Likewise, in October, we do an update. We can see that we're going to jump from 1 to 3 AM, and our times are getting adjusted on the destination side. So let's jump and have a look at the code of how we've done that. This is not rocket science, but it's just sort of demonstrating how you can use some of the libraries that we've been looking at tonight. So here's it's a simple web application, and I've just got a web API here. So I'm using the datetime providers class, which is provided by NotaTime, and we're using the TZDB provider there. We could have used the Windows provider if you wanted to, but I guess as I've been hinting, I think the IANA database is a bit more comprehensive and a bit more detailed. And apart from Windows, it's pretty much every other system is using it. And so we can then look up a named zone in that database. And so we're capturing that there. We're then reading a whole lot of data from a database table that I've got stored on my computer, which I've got some different routes from Adelaide to other different destinations. So for each destination, it has a destination time zone there, which so I'm doing a lookup of that. And I'm then calculating my times. So my start time is my Adelaide time, and so I'm associating that with the Adelaide time zone. So I start off with a local start time, which you'll see is a notatime.local date time. I then associate that with the Adelaide time zone, and it becomes a zoned date time. I then convert that back to an instant, so it's not no longer associated with a calendar anymore, and add however many hours, which defaults to 4 hours, but I can control that through the UI. The instant, I then associate that with the destination time zone. So my zone finish value is a zone date time. So I now have 2 zone date times, my start one and my finish one. And I'm also doing the calculation of what is the duration. So for each one, that should work out to be 4 hours, because that's what I've done as a calculation up here. I've done a bit of hard coding there, which is probably not ideal, but it works for the demo. And then I'm passing in the destination name. Client side, a little bit of TypeScript here, so it just generates JavaScript. So we've got our function here that we're receiving our data back from our call to the web API, and we just parse the date value, because that comes in as a date time and then a separator and then the time zone name. So we split that up, we pass that into the moment.pz method, and so we've now got our moment. We do the same for the finish time, and then we just poke that into our JavaScript object, and that appears on the screen. So this is just using Knockout, but it doesn't really matter what framework you use. I chose that because it was nice and simple. The other thing we are doing is we're using the isDST method here, which is something that the moment time zone library adds. So we're then able to show that on the page as to whether a particular time zone is in daylight savings mode or not. So if we jump back to the browser, and if we hover over a particular time, we'll see that DST is false there, and scroll down here, and DST is now true. So we're actually using the moment TZ to evaluate that property there. And so likewise over here, that's false, that's true, and Brisbane doesn't have it, so it'll be false there. Okay, so let's switch back to oh, good. Okay, so winding up. So in summary, when you're dealing with dates and times, think about the context. Sort of, do you just need to store a date? Do you just need to store a time? Do you need to be able to figure out if it's a UTC value, what the original value was for any reason? Consider the built-in types, and if you're going to run up against any of those limitations, then look at alternatives. So note time is a good alternative for the server side, and moment is one good alternative for JavaScript. Time zones, they really are complicated, and don't just think you understand it all, because I still don't. Be aware, particularly if you've got servers in different places, that you might have a different time zone for your backend server. You might have another time zone for your database, and then your end users, consider those as well. So you might have public customers with all their browsers in certain time zones, as well as your internal users that might have different time zones. Think about what dates are all those different users expecting to see. Are they expect to see in their local time zone or a different time zone? If you're going to be doing stuff with time zones, then think about how you're going to keep that data up to date. If you're going to use the Windows time zones, then you're going to want to make sure that you apply the Windows updates that come through from time to time from Microsoft that update the time zone data. If you're going to use the IANA time zone data, then you're going to have to figure out how you're going to maintain that data, as that also gets updated frequently. So think carefully about how you deal with dates and times. Some further reading, if this has piqued your interest, or you feel like, well, they sort of just covered a few things, but I really wanted to know more. There's an excellent course on Pluralsight by Matt Johnson called Date and Time Fundamentals. It's 6 hours of date and time, and Matt lives and breathes this stuff, and I believe he consults on this stuff. So that's also Matt's blog there, where he goes into a lot more detail some of the kinds of issues that you might come up against if you're trying to do dates and time zones and all that kind of thing. So as much as I can do in half an hour, Matt really digs in deep and goes in a lot more detail into what are the kinds of issues that you're going to come up against. Have a look at the NotaTime blog. John Skeet, who's one of the developers behind NotaTime, sort of outlines some of the issues that he's found with the base class library types. The code sample that I came up with is on GitHub, so you're welcome to have a look at that if you just want to see some really simple example of using those libraries. And with that, I'm done.
The irony of actually being finished on time, actually early, which is kind of amusing. Okay, so let's run through a few questions if we can. We shall jump over to the Q&A section. So we have one from Ken. It says, would time zone or TZ be more readable if it was longer as 2 time zones? Also, 2 instance is a widely used term. So,
yeah, I guess probably correct. Yes, 2 time zone would be more readable than TZ, but I guess that's just how it's been implemented. And TZ, I think, is pretty common when dealing with dates and times. So it's sort of a domain-specific term there. 2 instant, I guess that, yeah. Is it a widely used term? I'm not sure, but it kind of makes sense. And I guess there's only so many words they can choose to try and cover the different concepts they're trying to abstract. So, yeah, it's a good question.
It's a great answer. All right, so the next question from Raghu is, if you're creating a web API, is it good practice to always return UTC and let the clients worry about it themselves?
Yeah, no, that is a good question. I think generally UTC is probably good. Probably what I didn't really talk about it more was, I guess, UTC, datetime offset is potentially better if you can, in that it's as good as UTC, but a little bit better in that you've got the original offset there. So at least UTC, if not datetime offset. If you really need to be able to convert backwards and forwards, then pass in the time zone region as well. Just as, and that's going to be extra data, maybe as a second field or something like that.
Cool. And last one at the moment. Does Nota handle historical changes in daylight savings time, etc.?
Yeah. As I understand it, it's as good as the data that it's using. So be that the Windows time zone info or the IANA database. And that's where my impression is that the IANA database is more comprehensive and has more historical data. But even then, and I think remembering this from Matt's talks about the topic, is that even then, once you start getting back before the 1970s, then it does become quite problematic as to how good some of that data is. If you had a particular reason for wanting to go back further in time in the 20th century, I guess, you may have to do your own custom implementation.
All right, and we also have one more question, which is, any tips on mocking the built-in BCL datetime types for unit testing?
Yeah, good question. Yeah. It's kind of tricky, because if you're just using datetime.now or datetime.utc now in your code, then that's really hard to unit test. And I've certainly had, well, it always seems to be me that is the bunny that does the check-in at 11:59 p.m. and then has the unit test fail at 12:01 a.m. because they were hard-coded to expect not to be running at that time. So one approach is to use an interface for the UTC now and now methods. I mean, they're the most problematic. If you're passing values in and out all the time, then you can set them up for mocking, that's fine. But if you've got UTC datetime.now in your code, then if you can write your own interface and then write a class that implements that, which for production uses datetime.now, but for mocking, you can create your own mock and set the values as to whatever you like. I guess the other option could be what's the library that lets you intercept the static
Fakes.
types? Yeah, the Microsoft.
Yeah, Microsoft fakes and stubs.
Yeah, the fakes. That's right. Yeah, so you could go down that way, but that's a bit more of a heavy-handed approach. So yeah, probably just depends how much you've got invested in datetime.now already. Yeah.
Wonderful. All right, a quick check at the chat channel, see who's been hanging rubbish on you, which is pretty much everyone. I don't know if you've seen the chat while you've been doing your session, but
I haven't.
yeah,
I'm used to it. That's what happens at 9 to 5. So why not finish now?
hex moles, yeah, okay, yeah, for the testing. People are worried about time dilation. Apparently, how does time zone stuff work in computers when you're trying to go faster than light? It's a good question.
Yeah. Well, I guess the other problem is if you try and measure time too accurately, you probably don't know where you are anymore. So there's a lot of kind of physics things, isn't there?
All right, David, thank you very much for the session. So guys, it's time for the virtual applause again, if you're ready. Do the sound of one hand clapping virtually, which is complete silence, or going into chat and going clap, clap, clap. We will wrap this session up shortly. Feel free to stay in the chat channel. We're going to have a short break. What's the time? 1:15. So we're actually right on time. The irony of being right on time for the talk about time is not lost on anyone, I hope.
No. I could start singing right on time, but I won't.
Please don't. Please, no. So we will take a break, 15 minutes, which is enough time for me to go somewhere else and come back. And we'll kick in with microservices for our 9:30 session, or 7:30 if you're over in the Western States. And I don't know what the time is for you guys in Switzerland. All right, cool. Thank you very much. We will see you guys shortly.